Hello everyone, welcome back to the channel. Today we are going to uncover the real magic behind how JavaScript actually works under the hood. You've probably used setTimeout, written promises, or fetch data with APIs. But have you ever wondered why do some things get executed right away while others seem to be delayed? And why do promises always run before setTimeouts? Well, the answer lies in understanding the JavaScript engine, V8, the call stack, the event loop, Microtasks and Macrotasks, and the whole role of web APIs like fetch. In this video, we are going to take a single piece of code, a small script that uses functions, promises, setTimeout, and fetch, and go through it line by line, step by step. So by the end of this tutorial, you'll be able to explain and have a crystal clear understanding of how synchronous code runs, how tasks get queued, the difference between microtasks and macrotasks, and how the event loop orchestrates everything behind the scenes. So if you have ever been confused by the execution order of JavaScript, this video belongs to you. So without wasting time, let's jump into the code. So now what I'm going to do, we are going to write a piece of code to explain how everything revolves about how JavaScript works. So I'm going to open my VS Code from the terminal code. Then with that VS Code opened, I'm going to create a certain file. I'm going to call it index.js. Then from here, I'm going to say what? I'm going to say console.log started the programming. Okay, started the tutorial. Let's just have a tutorial. It's more logical. Now, with started the tutorial, what we are going to do, I'm going to have the different types of functions. So, number one, I'm going to have function first. I'm going to say console.log ended first. Now this one I'm going to copy it. Then this one is going to be exited. Now exited first. Now this one is going to be second. I'm going to have it like that. Second, going to be second. Now what I'm going to do, I'm going to duplicate this 3 times. This one is supposed to be second. Now this one is supposed to be third. Now this one is supposed to be ended second. This one is supposed to be ended second. Now this one is supposed to be third. This one is supposed to be third. Then now this one is supposed to be ended third. Then this one I'm going to delete. Then this one is supposed to be exited third. Now from here down, I'm going to say I'm going to call function first. Now this one is not enough to explain the whole idea of how JavaScript works. So I'm going to come up with another function. Let's have this one as an arrow function. So I'm going to say const calculate sum is equals to what? Is equals to, it's going to take a parameter that is a and b. Then of course this function should return what? A plus b. That way. Now I'm going to say const result is equals to calculate what? 60 plus 40, which is equals to 100. So what I'm going to do, I'm going to do console.log result. Now from there I'm going to have a certain function, which now this one is going to be it's going to be a macro task. You will understand how this one works. Let me just have I don't know. So I'm going to have so of course that one is 0, so this one is supposed to be console.log set timeout executed, set timeout executed, which is supposed to be a macro task. Now what I'm going to do, I'm going to come up with a promise dot resolve then we need to have a then there, then I'm going to have console.log microtask promise resolved. Then I'm going to have a microtask. Then I'm going to have then console.log microtask. Okay, maybe next microtask. It's supposed to be microtask. Then from there I'm going to have we need to have a fetch function here, and for that I'm going to come now back here, open with the next example power limited. Then I'm going to open what we just need a certain dummy API that is going to give us some data from the internet, so we see how the whole idea of fetching data works. So I'm going to say JSON typical placeholder. I had begun some, okay, let me just have a placeholder there, then I can just maybe close this, then I can now come this and pull this JSON typical placeholder, and I can just pull this print, so I can just copy this data here. So I can now come here and say of course now we need the first post. Let us pull it with ID first. Then this of course is supposed to be dot then supposed to be res. Now this one should return res.json. Now from there I'm going to have then this one should return data. Then I'm going to say console.log data. Now with that one, okay, I can just say console.log table data, then I can just clear this one like that. Let's now see what will first work if our code is working. So I can now say list, I can say node index. So that was okay. Let me now come here and say what, let me just remove that. Let me come here and say 1. Let me just put 1 there. Let's see, let me clear everything. So you see now the data has been displayed, but I can just remove the 1, just click. Okay, let's just have 1 and remove this table, just have console.log data. Then I can just clear everything, then run again. So you can now see our code has executed first. Okay, this one is supposed to be, let's see next have return a plus b. I've written some funny code here. Supposed to be, it's not supposed to be plus, it's supposed to be this way. Then we come now, we are trying to solve this none. Then we clear everything, then we run. So everything is running quite interestingly. Now we have our code running. So we have now this data that has been printed here that we are going to work with to understand how JavaScript works. Now let us now go into some very important things before we first navigate into working with our code. We need to understand one thing, that I had come up with a certain I want us to just use a certain typical flow here and just understand how these things work completely. So don't know why this one is bringing generate AI. No. Okay, it's okay. Now let us understand visually how JavaScript works. So in our understanding, we are going to have some items. Number one, I'm going to have that item, duplicate, copy, duplicate. Now in understanding how JavaScript works, you have to understand the three things. Number one, we have something we call what? We call call stack. Let us just add some. Let's just add let's just have some font. Let's just have some good font there. Now I'm going to call this one I'm going to call it call stack. Call stack, then name it. Now there's another one thing we need to understand. We need to understand something we call there's another thing here. This now we are going to copy it, paste it here. Now we have another one called there's something we call web APIs, and there's another one we call, if maybe we are working with Node.js, apart from just JavaScript, we have something we call libuv. Then we have another one. There's something here we have called there's something we have here called Microtasks. We have our microtask there. Then of course we can just we have another one. You have something you call macrotask like that. Then of course we have something called event loop. Let me just copy this. You have something we call event loop. Now there's a tutorial I had recorded about how JavaScript works, and we had just introduced ourselves into event loop. Now JavaScript is single-threaded. What do we mean with single-threaded? It operates in a certain systematic order, in that work is handled by something we call event loop. This event loop, we say it is semi-infinite, and I will explain what we mean with event loop being semi-infinite. But we have to understand that for you to know how JavaScript works, you have to learn about the call stack, the web APIs, microtask and macrotask. Now this event loop is like a task manager. It manages how various functions are worked upon by JavaScript. Now with our code here, console.log started the tutorial. So what happens when we are executing any JavaScript code? When we are executing synchronous code, number one, what happens is that there's something we call call stack. Now This is how it works. First of all, this function here, when JavaScript runtime is executing, is interpreting the code, this code here, number one, this function is forwarded into the call stack. Now, this call stack operates by a certain mechanism we call LIFO. LIFO. Now, LIFO stands for last in, first out. Last in, first out. Now, what happens? Number one is that this function, when now JavaScript wants, when now V8 engine wants now to execute this function, this code, what will happen is that this console.log will first of all be fed into the call stack. Number one, when it is fed into the call stack, it is now first going to be executed before now proceeding to first and second and third. So what will happen? This call stack will execute started the tutorial by console.log started the tutorial. So if I look at our data here, we see started the tutorial was executed the firstly. Now, because synchronous code is executed inside the call stack. So basically, JavaScript have different components. There is a call stack, there is the web APIs. If you are dealing with the web browsers, if you are dealing with Node.js, you are dealing with libuv, you are dealing with even loop, all of those things. Now, after this is executed, it is now, after this now is taken and it is placed in the call stack here, it is first of all executed. After now it is executed, it is entered, it is executed, and it is now removed. It is popped out from the call stack. So it is last in, first out. It is now fed into the call stack, executed, then after executed, it is popped out outside the call stack. Okay? Now, when it is popped out outside the call stack, now this function now here is now fed into the call stack again. This function first, it is now fed into the call stack. Now, if I come now and say, let's just continue with this. So after this one is fed into the call stack, it is executed and then popped out. Now when it is popped out, the call stack is empty. When it is empty, now this function first, it is now fed into the call stack. Okay, when it is called, when you call this function, it is fed into the call stack so that it can be executed. Now inside this call stack, first function has been called inside. Now what happens is that ended first, this console.log, now this one is now queued into the call stack. Just a minute. Now this console.log, this one is now pushed, because now this one, remember this function is inside the call stack. So console.log ended first. It is now pushed inside the call stack. It's quite funny. Now when it is pushed inside the call stack, it is now executed. Remember, this code is synchronous. Now what happens is that when this code has been executed, remember we are flowing from topwards towards downwards. Now this second function, you see, ended first, it's executed. Ended first is executed. Now when it is executed, ended second is fed now into the call stack. Okay, ended second is fed into the call stack. Okay, now when it is fed into the call stack will now get into second function and now find out that ended second is the next function. Now this function is now going now to be fed, because console.log is a function. It is now going to be fed into the call stack. Now when it is now fed into the call stack, it is now executed ended second. So when we look at now, it is now started the tutorial, ended first, ended second. Now inside this call stack, after entered second has been executed, now the code flows and finds that there is that function that has been called inside the second function. So what happens? This call stack will now call function that. It will now execute entered that. Now because this console.log entered that is now next one, now on the call stack. It is now pushed into the call stack. Now this one is executed and entered that is printed. Now if you look at now here, entered that, let me just add the font. Let me just add the font. No, let me just add the font. Let me just have the font. Now you see, now entered that has been executed. Remember, we are following the order synchronously. Now when entered that has been executed, the next function to be pushed into the call stack, now it is console.log exited that. Now when you come back here, exited that is executed. Now when that is executed, the function will now go back to second and find out that after that has been executed, console.log executed second has not been executed. Okay, console.log exited second. Now this one will be executed. Now when you come back here, exited second has been executed. Now when it is executed, it now goes back to the first and find out that after second, console.log exited first had not been printed. So this one will be now the next function to be pushed into the call stack. Remember, when this function is pushed into the call stack, it is popped out. So in an asynchronous manner, there's no way you can have two functions in the call stack. Maybe when the functions are calling themselves each. You see, for instance, this one, you can have multiple functions in the call stack because these functions are constantly calling each other. But when this function had been executed and this function is not calling any other function, you find out that this function was popped out because it is not calling any other function. And when it was not popped out, it made the call stack to be empty, and now call stack being empty, it was able to be fed another function. You see, now that is how now JavaScript works. Now you have to understand one thing when you're dealing with JavaScript. Any synchronous code, it is executed at the call stack. Now what manages this data from moving from call stack, web APIs, libuv, it is this thing we call event loop. Because this event loop, you can preview it like a receptionist in an hotel. Receptionist can handle the guests who are coming to the hotel, maybe to book for rooms. The receptionist can handle the guests who are there, maybe who need food to be served. The receptionist can handle what is now being cooked in the kitchen. So this event loop is like a manager that manages data or execution of program in a JavaScript code. Now, let us now proceed. Now that has been executed. Now function first has been executed. Remember, it was this first that had all of these functions because first is calling second is calling that is calling no one. So that was popped out, and first, because everything has been executed, is popped out. Now when first is popped out from the call stack, you find out that when this first, you see, let me see, so this function first, after it was executed, it gets popped out. You see, now when it is popped out, you find out that this call stack now is empty. So remember, we are moving synchronously. Okay, now when this one now is empty, we proceed now to the next function in the event loop, that is in the task manager. Now the event loop now comes here and find out that there is the calculate function that is now supposed to return a plus b. Now this function is now called into the call stack. Well, now it is called this function in the call stack. Now this function is evaluated inside the call stack, and the value that is 100 is assigned to a certain maybe a place in the memory that is called result. Is assigned that total amount that has been calculated. Remember, now here inside we have another function we call calculate function, calculate sum. Calculate sum. Now when this function calculate sum is executed, now you see now console.log, when this function is executed, because this function stores data inside a memory location called result. Now this console.log result is now the next one in the execution flow. Now this one is popped out, and this one console.log is popped in, and it is now the one now that prints the value of the result. Okay, now this one, you see this like this. Now this one is popped out, and now we have now console.log. Now console.log. Now this console.log, it prints now the result, which now we have here, which is 100. Then after now it prints the result 100. After it prints the result 100, what happens? Now we proceed to this function called setTimeout. Now understand one thing, that in any JavaScript code, when you are dealing with the synchronous code, it is executed inside the call stack. From here above, all of this data here, all of this code is synchronous. Synchronous means that for you to go to step B, you must pass through step A. That is how we mean with the synchronous code. It is a block in code. If there is something wrong with a certain place in the code, it will break the execution flow, and it will make JavaScript being single threaded, not to execute the other code beneath it. Now we have another funny code here, which is not a synchronous code. We have now setTimeout. Now what happens with this setTimeout? This setTimeout, just a minute. Now setTimeout is not part of JS. It is provided, it's not part of JS. It's provided by libuv or web APIs. Now you have to understand one thing, that when you're dealing with the JavaScript, there are two versions of JavaScript. There's the version of JavaScript that will run on the web browsers. That is JavaScript for the client side applications. There's now another JavaScript that runs on the server side. That is now the Node.js. Now in Node.js, we have a certain library we call libuv. Now this libuv is a library that was designed by, it is coded by C. It is coded by C. Now, when it comes to web browsers, there are certain APIs called web APIs that are not made by JavaScript, that are made by C. Now you find out that this setTimeout function is not a JavaScript code, because this one is a synchronous code. Remember JavaScript is single threaded. Okay, so this one is not a JavaScript code. We have written it in JavaScript, but now it has to be executed by something else which is not JavaScript. Now in our case, if we are writing this on maybe React or Angular, this one is executed by something we call web APIs. Web APIs which are provided by the browser. Now when you are running this one on the server side, it is executed by a function by this library we call libuv. Now this library is a library in JavaScript or Node.js environment. It is a library that manages async flow, asynchronous applications, asynchronous functions, maybe like file reading operations, database reading operations, network issues. Now it manages that, because that one now does not deal with the JavaScript, because that one requires more functionalities which are not single threaded. Now this libuv contains certain functionalities that makes JavaScript work like a multi-threaded language. Now, this libuv, it has certain functions. We call them worker functions, and it has a thread. It has different threads. So by default, libuv works by 4 threads, but you can literally, it's just a small micro threads, but you can literally transform those. You can literally define how many threads to work with. But by default, you work with 4 threads. You can just come here and say process .env .thread pool, supposed to be thread something pool, supposed to be thread pool. Then you change to 5. You want how many thread pool, but by default libuv works with thread pools. Now what happens is that now let's explain now how this setTimeout now is transformed. It's not executed inside the call stack because it's not asynchronous code. It's executed inside the libuv. If you're dealing with the Node.js, or when you're dealing with the web APIs, it is executed in the web browsers. Now, setTimeout is not part of JavaScript. It's provided by libuv, Node, or web APIs, that is browser. The callback is registered in libuv's timer queue with delay 0. It will be executed as a macro task, not now, only once when the call stack is empty. Microtasks has been processed. Now, there's something we call microtasks. There are different type of tasks in JS. Now, these are different types of tasks. We have 2 different types of tasks. Let me just we have microtask. We have microtasks and we have microtasks and we have macrotasks. Now, anything to deal with setTimeout, set interval, all of those things, timers, it is now termed as a microtask. But now, this microtask, it has to be executed only after everything in the call stack has been executed. After every synchronous code has been executed in the call stack. Once the call stack now is empty, it is now this libuv that will execute this macro task. Understood? Now, this, when you look at now here, let's see, promise resolved, next micro task. Then of course we have setTimeout, macro task, of course. Now, then we have this data. Let me now explain this. Now this setTimeout, setTimeout, it will be executed as a macro task. Not now, only once when everything here has been executed. So in an event you have most of them, you find out that we have a macro task queue. This setTimeout, we have maybe I can just come here and say maybe you can just have index.txt, rename txt. Here we have macro task. They comprise of timers, set timers, and so on. These are macro tasks. These are categorized as micro tasks. Now understand this. Macro tasks are executed only when everything in the call stack has been executed. So what happens, because call stack has not yet been executed, what happens is that this setTimeout, it is now been queued. Now let's proceed. Now we have now promise.resolve. Now this one is asynchronous code. This one is not asynchronous code. It is asynchronous. Now this one is not dealt with the JavaScript, it is dealt by libuv or web APIs. Now what happens is that fetch is delegated to web API. That is when you are dealing with the JavaScript for front end, if you are dealing with the React or Vue.js, or Node.js when you are dealing with libuv. Remember, this one is a network call because no, that one is not a network call. Oh, I just jumped this one. So I jumped to this one. So promise, let's look at promise.resolve. Promise.resolve instantly resolves. Okay, let's understand it very well. Let's just understand it very well. So first this dot then first is pushed into the microtask. Now this promise.resolve it belongs to a certain class called microtask. Now, and this remain to a certain class called macrotask. This is microtask. Now, in JavaScript execution, microtasks execute first before macrotask. So when this function has been executed by the call stack, macrotask queue will now execute this before this is executed, because of performance issues. And that was the main reason why V8 was introduced by Google in the year 2008. Because of priority issues, because of performance, promises are given highest priority. Because of performance, they are given highest priority instead of timeouts or set timeouts. So in this code, immediately the call stack is empty. It is now the microtask that will be executed. So what will happen is that promise.resolve will instantly resolve. Then .then is then pushed into the microtask queue. When that microtask runs, it schedules the next .then. So when this one runs, it schedules the next .then, okay, as another microtask. So microtask, always understand this, always run before macrotask. Always run before macrotask. Okay, always run before macrotask. So promises, they'll run before timers and set timeouts. Okay, now let's now proceed back now and come here and see now how this one now will work. So now this one explains the idea why after this result has been printed here 100. You see, it's like JavaScript is jumping this and then it's now coming here, promise resolved. See, promise resolved. Then next microtask. Then what happens next? Now it goes back to this set timeout executed macrotask, because microtasks are given highest priority above macrotask because of they are given that priority because of performance issues. That is to make JavaScript high in performance. Now let us proceed further to fetch. Now this fetch is not handled by JavaScript. Now for the case of web browsers, this one is handled by web APIs. So this one is a network call. You are calling a network to a certain resource in the internet. So what happens is that fetch is delegated to web API when you are dealing with the browser, or Node.js HTTP module when you are dealing with the libuv. Actual HTTP request happens in the background. So these requests are happening in the background while everything is running. These requests are happening in the background. Now when the response arrives, that is then, where is this then results, when it arrives, is queued as a microtask. Now this one is queued as a microtask. So this one is considered as a promise, because this one now returns a promise is queued as a microtask. So when now it is now queued as a microtask, after is queued as a microtask. So now this one now is returned. Now this one is now returned. Now after passing JSON, the next dot then. Now what we are doing here is we are passing JSON data. So the next dot then is queued as another microtask. Now this happens later, not immediately. Now this one is that works the latest. Now if we come now and say console.log code finished execution, and I come now here, you see it was the last one. So if I come now and clear everything, then I do like that, you see code, let's see okay, code finished execution. This it was only after all asynchronous functions worked. Then the next asynchronous function is code finished execution. Then from code finished execution, the next one to proceed is a microtask. You see, promise resolved, next microtask. Then from the microtask, now you proceed to macrotask. It is now the macrotask that is now printed out. Then now the fetch now resolves, and then now we get everything. Now all of that now is now that. Now let's now see. So event loop is like a manager. It manages everything. Now the way libuv is function. Now the way libuv works in the Node.js, it's quite a broad topic that we need another tutorial to explain in deeper. But let's now look at maybe from Greeks to Greeks. Let's look at microtask and macrotask. Let's just look at them and see how within event loop. What are the microtask and macrotask within an event loop in JavaScript? An event loop in JavaScript is said to be a constantly running process that keeps tab on the call stack. Its main function is to check whether the call stack is empty or not. So it checks whether the call stack is empty or not. I told you it's like a manager. It checks whether the call stack is empty. It's now forwards the next function. If it's empty, it proceeds to libuv, microtask queue, all of those. So inside the task queue, the tasks are broadly classified into two categories, namely microtask and macrotask. Microtasks within an event loop. A microtask is said to be a function that is executed after the function or program within which created it exists, and only if the JavaScript execution stack is empty. But before returning control to the event loop being used by the user agent to drive the script's execution environment, a microtask is also capable of enqueuing other microtasks. Microtasks are often scheduled for things that are required to be completed immediately after the execution of the current. So this is now the importance of microtasks. Are often scheduled for things that are required to be completed immediately after the execution of the current script. On completion of one macrotask, the event loop moves to the microtask queue. The event loop does not move to the next task outside of the microtask queue until all the tasks inside the microtask queue are completed. This implies that the microtask queue has a higher priority. Now that's the main reason that the microtask has a higher priority. So for you to go deeper, you need to maybe pass through these let's say Greeks. libuv. Let's check on libuv. Let's check on libuv. So Node.js relies on various dependencies under the hood for providing various features. We have V8, libuv, LLH, HTTP, CRS, OpenSSL. libuv is one of them. Let's discuss. So you can just pass through these articles, and I believe so this is what I told you, that you can now come here and say, if you want to change maybe the thread pool in maybe in the libuv, you can now come here and say process dot env dot uv thread pool size. So this is what I was speaking about. You can now change to 5. Then features of libuv, fully featured event loop backed by Apple Linux, asynchronous TCP net module, and a UDP, all of those. But libuv is basically a library that helps in synchronicity in JavaScript that was coded by C. It basically deals with asynchronous code. So enough of that is set. You can maybe like, share, and subscribe so that you can continue reaching more people, and we can now continue enlightening more people, and we can contribute to proper code writing, and we can help each other grow, and we can maybe understand how programming is done in a deeper perspective. You can have a good time. Thank you for listening to me.